we do, we can design, build, and then maintain the things that make technology work. First off, we're all familiar with software. You know, people like to program. You know, nowadays we're teaching programming in school, and you know, people are learning how to do, say, an app for an iPhone or an Android phone. We also do the hardware part. I mean, somebody had to come up with how all the electronics fits in this little package, which was unthinkable even 20 years ago. You know, back when I got started in radio, two-way radio, you know, there were huge boxes that had to go in the trunk of a car, and you had, you know, you see the old things where the person picks up a microphone and it comes out the speaker, and that was the way how you talk from car to car. Nowadays, of course, everybody picks up, you know, you just hit the Bluetooth button, or just say, you know, car, call, you know, Jane, and it does it. You know, we've come a long way from that. Energy systems, like I talked about, you know, the transmission lines that you see out there going across the campus, you know, which are as much of 1,000,000 volts of electricity going someplace, it gets changed down to the 115 volts it's used to at home. How do you figure out how all the stuff goes into buildings? I mean, a building like this with all these lights and controls, and you see all the controls on the walls for alarm systems, for heating systems, cooling systems, all of that has to be figured out, so there are engineers who do that. We do industrial controls. If you've ever seen a factory and all the things that go on in factories and how they work together in order to create something, say to build a car or to make, say, that phone, so we work with industrial controls on that. We work in medical electronics. If you've ever seen how it is in a modern hospital or even a doctor's offices with all the gadgets out there, everything from the electrocardiogram to testing and whatnot, all of that. And there's much, much more that's involved in this. The IEEE, the group that I'm representing here, has over 37 different societies or groups of special interest out there showing the different things that we work in. And I'm not going to read all of these. These slides will be on the website, but this just gives you an idea of where you can go with an electrical electronics or computer engineering degree. We work everything from aerospace, down here manufacturing, of course the Computer Society working in computers, and the next session after this is going to be about computer science in particular. Information theory, automation, industry, medicine and biology, which I work in. And of course there's the Education Society, there's people who teach engineering, and there's more. We talk about microwaves, oceanic engineering is part of electrical engineering, because who figures out all of that instrumentation out there that's determining what the oceans are doing? We talk about the ocean levels rising. We talk about how we know that a special wave is coming someplace, perhaps a tsunami or something even smaller, say we've had a storm someplace, how we know things are going and how the tides are working. All that requires sensors and controls and communications that are all part of electrical engineering. You see parts in here, of course, Robotics and Automation Society is one of the sponsors of this particular conference. We'll be talking a lot about robotics as we go here, signal processing, etc. And on top of that, there's other special interest groups. Some of the ones I'm involved in. Smart cities, we talk about, you know, how do we make power even out so that we don't have to build more power plants just because on one day, every other year, everybody turns on the air conditioner at the same time. There are the things we can do to keep from having to build another, you know, millions of dollars of power plants and pollution, etc., just to make the needs of those few days. It's a big problem that we have to look at. Of course, internet technology, etc. We have councils also that are involved. We even work in nanotechnology. You can talk about things that are so small, such things as a sensor, a pill that you can swallow. As it goes through you, it senses what may be wrong with you. All these things are being worked out. So these are different parts in there. How did I get into this? A little bit of personal story. I started out, like I said, I went to NC State here, graduated from here. I went to a company called ITT Telecom, which was located here in Raleigh. And I first started getting involved in computer controls for those telecommunication systems. Then I went to Northern Telecom, which is also here. I got involved in two-way radio, like I said. I was actually involved in the first test cellular site. The first cell site built in the U.S. was actually here in Raleigh, North Carolina, and we were proud to be part of that. Worked in government contracting. Some of you may have heard of RTI. out in the park. I didn't work for them, I worked for another one of their competitors, where we did a lot of medical, military, even design stuff that went up in space for the space station. I worked in instrument calibration, I worked for pharmaceutical, had a big pharmaceutical company happened to be located here. I worked in software HD TV, or high definition TV, which of course is the TV that we know nowadays, processing. For the last about 14 years I've been doing consulting, actually go out and do training of other engineers. It's always something new, always exciting. You notice I've been in a lot of different fields. That is part of how engineering is today. Engineering is not just about sitting in a cubicle being Dilbert. For some people it is. Many here are familiar with Dilbert. Okay, I need to educate some of you. But no, Scott Adams wasn't an engineer, and he was a cartoonist, and he combined the two and came up with this character called Dilbert, who was a prototypical little engineer who worked in a company. But it's always something new, always exciting. Typically, if you go into engineering, you're not going to be doing the same thing every day for the rest of your life. You're going to learn new things because technology changes. When I was in school, we were still learning about vacuum tubes. Who here knows what a vacuum tube is? You know, it's a big transistor, it's got a big light bulb in it. But we also didn't have calculators back in those days. We used slide rules. So I mean, a lot has changed in my lifetime, and a lot will change in your lifetime for young people who are looking to get into this. As I say, I was established in 1978, that's when I got my first engineering job. So I've been around for a long time. Some of the things to think about if you're interested in engineering is get involved with professional societies. IEEE does outreaches in kindergarten through 12th grade. We also are very heavily involved in college. Keep current, like I said, I learned about vacuum tubes and slide rules. The things that you know today, say, this phone, what's the next thing after this? Who knows? We could have told you that we'd be carrying these little boxes around, you know, with our faces stuck in, looking at Facebook and Instagram and whatever all day long. And yes, you do, I know. You have to be resilient, you have to be resourceful, and you have to be flexible. So if you like adventure, engineering is an adventure. It's not just sitting at a desk, sitting there doing something on your computer every day. It's something new every day. And it's a very exciting field out there. The people who are potential engineers in school are people who love math. I was a math geek. I'm not ashamed of it. I loved math. I went to math contests. You know, I see some smiles out there. I know some of you are feeling that way too. But we were the math and science nerds and stuff, and we're proud of it because it leads to all of this technology that makes our life work. You have to be innovative, intuitive. I was the kid that my dad owned a drugstore. He would get all these big displays and stuff, you know, that we put products on, and half the time they'd go with no instructions. And so he'd say, send my boy over here. And I'd sit there and look at the parts, and I'd figure out how that thing went together. So no, I didn't just tear things apart, I actually put things together too and learned how to do it. It's that type of thinking that says, you're probably going to be an engineer. There is a stereotype out there about engineers being the type who sit in front of the computer and don't talk to other people. You know, being the loners, being the introverts. In many cases that's true, but there's a lot of extroverts too. There are people like me who get up there and do engineering. We're not the ones who are happiest being in a cubicle all day long. We're the ones who like to get out there and make things happen. I'm not going to take a lot of time and show you. I do tell you go to YouTube and search for Dilbert the Knack. It's a great little video. We might show it to you later. It's funny. It's about this engineer as a kid. His mother takes him to the doctor and says, I don't know what's wrong with my son. He's doing weird things. And she said he took the TV apart back in the days when TVs, you know, were actually a big box and not just a flat screen. And the doctor said, well, kids do that. She said, yes, but he took the parts and built a ham radio out of it. So it's like, okay. And so the kid's sitting there in the doctor's office fixing various medical equipment that was broken, sitting in the corner of the office. And the doctor turns around and says, it seems that your son has the knack. And she says, what does that mean? It means he's going to be an engineer, in which case, of course, she, being comedy, she breaks down crying. But actually, it's an exciting thing. And one One thing you may hear in the press talking about that we have too many engineers in this country, there's not jobs out there for engineers. I got another thing coming for you. There are engineering jobs everywhere, even though I guess there are some layoffs. I just got back from a company where two companies merged, and so they're laying off engineers. It does happen. I've been laid off 4 times in my career, but I found another job. So there's always jobs out there. We need to keep things here in the U.S. You know, you hear that a lot in politics. Well, the way we do it is by having the skilled people who can do the jobs. So I highly encourage people to be in technology, to be in engineering. There isn't always will remain a need for more and better engineers. So if you think you've got what it takes, I highly encourage that you do it so that you can be making that next big thing. We've got a lot of technology coming down the pike. Cars are getting smarter and smarter. You know, when my first car didn't even know what a computer was. You know, you get under the hood and you sit there and tweak things. Nowadays, the car that I drive, which is actually 3 years old, has over 50 computers in it. I mean, I call it my software mobile because I'm always having to upgrade the software on some part of it. You know, just like you do for your phone, for your computer in my car now. That's going to be the future of it. But cars are getting smarter. They can tell you if there's somebody sitting in your blind spot. They can tell you, you know, now it's not going to be very long until you'll be able to hit a button and take your hands off the steering wheel and let the car drive itself. I'm not quite ready for that myself, but I mean, I have actually been in demonstration vehicles that do that, but not on city streets. I mean, Raleigh traffic's bad enough as it is. We need those engineers out there. So I always encourage young people to be engineers. It is a great profession. It's a lot of fun, and it is an adventure. That was my thing. I actually ended up being short. That's good. But what questions do you have? Is everybody ready to go out there and engineer? Are you ready? Yes, ma'am.
What was one of your favorite projects that you worked on so far?
Probably the one patent I own is for a percussive vest. It was a controller for a percussive vest that was to help cystic fibrosis patients breathe. Cystic fibrosis is a terrible lung disease that, as you would tell by the name of it, is that you get this cyst, or actually fibrous cyst building up. And about the only way that you can clear their lungs is to lay them down and sit there and beat on them as such. You know, there's a special way of doing it with the cupped hands and hitting them. And it's very labor intensive for, say, a parent or a caregiver for a cystic fibrosis child. Was a lot of work. We came up with an automated vest that did this. Now, you can't just make a device that sits there and beats on somebody without any feedback controls, because you don't want to hurt them. So we came up with a system that determined, you know, that we weren't hurting them, but we were actually effectively breaking up the fibrosis in their lungs and help them breathe. This was something that's sponsored by the Cystic Fibrosis Foundation, and it's still in use today. So that's probably my favorite project. I love helping people, and I mean, that's something that actually leads to better folks. But thank you for that question. Or $1. Any other questions? Yes, sir. I mean, I didn't catch the last part of that about the job situation.
No. How important do you think your education, go on and get a master's or a bachelor's, or is it just bachelor's and then all the employment opportunities?
I am prejudiced because my job is actually to go out and do continuing education for engineers. I teach engineers about the newer technologies. There are a lot of engineers that, like myself, learned in the days of vacuum tubes and buggy whips and whatnot. And so now we have all these new technologies. How do you learn how to do this? You may have heard the term Internet of Things or smart cars or all these things that are coming out there. How do you know these technologies? Well, there are ways of learning that. So continuing education, and that is kind of a hole in this country right now. We're trying to do something about that within the IEEE to provide that type of education. Going back and getting your master's can be good. Right now, personally, and this is just personally me, I do not recommend necessarily going to any MBA. That used to be the big thing, so that you could go, you know, be a manager, etc. In some cases, that's true, but there's a lot of people still looking for work that took the time and the money to go get an MBA. It's not necessarily the route to go. But again, staying current day to day. Don't wait. Once you're an engineer, don't wait until you need some new skill later for another job to learn. Our profession changes into new things, in my opinion, faster than the medical field. You know, doctors have to be up on everything day to day to day because, you know, the medical field, they're learning new things. And it's the same thing in engineering. Like I said, you know, my phone or my car is obsolete in 2 years. My computer is obsolete in 2 years. Although I'm not going to Windows 10 yet. You know, but there's things changing. You have to be ready for it. And you have to have that environment in your head of continuously learning. Does that mean you should essentially stay in school all the time? Yes and no. You know, it can be fun. Some of you I know, when I was a young person, you know, I sit there and say, I've got to keep going to school after I get out of college. Well, in a way you do. You know, read, keep up with the web now. You know, it's all out there, so you can learn about new technologies to stay current. Because the next job is going to need some new skill. And if we don't have, the people here in the current job market don't have those skills, that's when the employers say, there's nobody in the U.S. can do this, so we're going to go get a visa and find somebody, you know, in Pakistan or whatever that knows that job. And so if we don't stay current here, it's our fault that we lose the jobs. Because they're going to find somebody who knows that. But that's my biggest thing, is staying current in the technologies themselves. Not so much about going and getting another degree. I know NC State would love to give you a master's or even a doctorate in electrical engineering. But I will pit my 38 years of experience up against a PhD any day. Any other questions? Yes, ma'am.
Do you find it easy for students who are coming out of school, let's say with an AS degree, that companies are willing to do continuous training and bring them on and train them so that they get the experience to move up with a company?
In the good old days, that was very much the case. IBM, Hewlett-Packard, Bell Labs, back in the days of the huge companies that fostered such things as Apple Computer would not exist today if there wasn't a company that was supporting their people and learning new things and doing new things other than what they were being paid to do. That's where those companies came from. Unfortunately, when the shareholders don't get quite enough money for the quarter, companies cut back. And they cut back on training first. Unfortunately, that is the case. And that's, in my opinion, again, that's how we got here. And so, I'm out of time. I've run over now. And so it's time for us to go on to our next speaker. And are you going to introduce them, or are we just going to bring somebody up here?
Daniel's right over there. I was hoping for self-introductions, just to keep things moving, but...
Okay. Thank you very much.